For number 14, we're being asked to do Lewis dot structures and look at VSEPR shapes. We're starting with NF3. That'll be nitrogen with 3 fluorines. Each nitrogen brings 5. We have 3 fluorines, each bringing 7 for 26 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and one up here is 26. That will force it to be trigonal or triangular pyramidal. The next one is Br2. This is 2 bromines. 2 bromines each bringing 7 gives me 14 electrons. If I put a bond between the 2 bromines, that's 2 of the electrons. That leaves me 12, which means each bromine is going to have 6 electrons in 3 lone pairs. Our next one is CF3Cl. The one that you're most familiar with is the tetrahedral with CH4. Carbon, we said, always goes in the middle. We're going to have 3 Fs. And 1 Cl. And each one of those gets 6 electrons to itself. The carbon is satisfied by the 4 bonds that it makes in the center. That means this is going to be a tetrahedral. Our next one is our cyanide atom, or ion, that we did in our notes. Carbon brings 4, each nitrogen brings 5, and the negative charge gives me 1 more. I put a bond between them, that's 2, 4, 6, 8, 10. Put brackets around all of our ions and the charge on the outside. The next one we have is H2Se. We recognize that selenium's in the same group or family as oxygen, so it's going to look like water. We said water was O with the 2 H's kind of hanging below and 2 lone pairs at the top. Oops, I even did that, didn't I? That should be RSE in the middle, shouldn't it? And it's bent. Next one's HBr. Hydrogen brings 1, bromine means 7 for a total of 8. Remember that hydrogen only needs access to 2, so the other 6 electrons can go around the bromine. That means this is going to be linear. And I should have noted that this one up here is also linear. N2, another one of our diatoms. 2 nitrogens each bringing 7 gives us 14 electrons. There's 2, 4, 6. Sorry, let's go back over that one. Big mistake on the teacher's part. Nitrogen only brings 5. 2 times 5 is 10. Nitrogen to nitrogen, that's 2, 4, 6, 8, 10. He was our example of a triple bond. He's also linear. NH4, ammonium, the ion, has a +1 charge, so that's 5 for the nitrogen, +4 for the hydrogens, -1 for the positive charge gives me 8 valence electrons. That's nitrogen. I'm going to have 4 hydrogens around it. That completes everybody's octet. Got to remind you that I'm positive and that I'm a tetrahedral. We have BBr3. Boron, remember, is one of our exceptions. He's bonded with bromine, who's a halogen. So that means boron will only make 3 bonds. They want to be as far away from each other as possible, so we have a bond angle of 120 degrees. And so this will be trigonal planar. SF6 is another one of our exceptions, sulfur with 6 fluorines. And these should be at the very end of your periodicity notes or in the molecular geometry summary that we posted online. Everybody gets 6 lone pair, or 6 electrons and 3 lone pairs around it. And we said this was octahedral. Pi5, another one of our exceptions. This is phosphorus with 5 iodines around it. Again, iodine's member of the halogen family. We said phosphorus with halogens was going to be allowed to make 5 bonds to give him 10 electrons around him rather than usual 8. We call this shape trigonal bipyramidal. Pyramidal. Okay, we've got 2 more. HCl, hydrogen with a chlorine. Hydrogen brought 1, the chlorine brought 7 for 8. Hydrogen only needs 2, so the other ones are going to be here. It's going to be linear. And our last structure, CO, carbon monoxide, 4 from the carbon, 6 from the oxygen, for 10. 2, 4, 6, 8, 10, also going to be linear. So be sure that you can use Lewis dot structures and valence electrons in order to come up with the Lewis dot structure, which will lead you to the shapes.